Hello friends, welcome to another session. In this session, we'll be discussing about bridge rectifier circuit. In this session, we will see what is the bridge rectifier circuit and how this circuit works in order to produce the DC output when AC input is applied to the circuit. We are also recording this session on iPad and we will be making use of the notability software in order to deliver the session. So let us start the session. So here we will discuss what we mean by bridge rectifier. Bridge rectifier is a rectifier which can be classified as a full wave rectifier. So this rectifier is a full wave rectifier. That is, this rectifier will convert the input AC voltage into DC voltage, and while performing this conversion it will make the use of both positive and negative input cycles. So as we know, rectifier can be classified either as a half wave rectifier, where it will make the use of only half cycle, or the rectifier can be classified as a full wave rectifier. So bridge rectifier is just nothing but a full wave rectifier. So this is a full wave rectifier which will convert the input AC into DC. So this rectifier will require 4 diodes. As we have seen full wave rectifier circuit, so a normal full wave rectifier circuit will require only 2 diodes and a center tap transformer. But if you do not have a center tap transformer with you, then in that case you can go for the bridge rectifier, and this bridge rectifier can be constructed without using center tap transformer, but it will require 4 diodes. The advantage of the bridge rectifier is that it is a full wave rectifier, so its efficiency is at par with the full wave rectifier, and also you will find that the peak inverse voltage that the diode will have to withstand is much less in case of bridge rectifier. So now let us go for the circuit diagram of bridge rectifier circuit. So initially, in every rectifier circuit, what we need to have is a transformer. The transformer normally used is a step down transformer. So at the input of the transformer, we will apply 230 volt AC, and at the output we can get a low AC voltage such as 6 volt AC. So you can select the transformer as per the need of the rectifier, or as per the desired output voltage to be obtained. Now this is a bridge rectifier, so the circuit itself will consist of like a bridge, where we will make the use of 4 diodes. So this is a bridge rectifier consisting of 4 diodes. This diode I will call it as D1, this diode I will call it as D2, this diode I will call it as a D3, and this is the diode which can be called as a D4. So you will find that the output that we need to obtain will be obtained over here. So here I will connect some load resistance RL across which we can obtain the output. So this is a circuit diagram. One can easily find that here we have not used a center type transformer. So when we apply the AC input to the primary of the transformer, and suppose these are the secondary terminals S1, S2, these are the primary terminals P1 and P2. So during the positive half cycle, S1 is positive, and when S1 is positive, one can easily find that diode D1 and this diode D2 will become forward biased, and therefore the current will flow through the diode D1 and then through the load resistance RL and then through the D2. So D1 and D2 will conduct during the positive half cycle. During the negative half cycle, when S2 is positive with respect to S1, then one can find that this diode D3 and this diode D4 will be forward biased, and therefore the current will flow through the diode D3 and D4 and then through the load resistance RL. So D3 and D4 will conduct during the negative half cycle. So one can easily find that the current that is being flowing through the load resistance RL in both the cases is only in one direction, and therefore we can say that the output that is being generated will be DC. That is, if we plot this output, then you will get such type of the curve at the output. So the advantage, as I said, with this circuit is that this circuit do not require a center type transformer, but it will require 4 diodes. And also, since we are making the use of 4 diodes, the peak inverse voltage of this circuit, which we call as a PIV, is only half compared to that of other full wave circuit. So thank you friends for viewing the